sir. How are you? Just careful with my tripod. Huh? Good afternoon. Oh, jersey. No, sometimes it's not a jersey. Where's the rest of the other guys? Also, Maremba Tess Mosova. Look, I've been a student as well. Oh. No, it's all good. But how was the test, by the way? It was okay? So this is where I just expect a person to just raise up their hand and just give a view of how the test was. I heard someone talking about time. You want to say something about that? Look, listen to me. If you want to talk to me, I want to know how to set an exam. So this is me trying to get a feedback. Was the test easy? Was it hard? Was it about the time? And where can we improve? If you keep quiet, hey, Abban, can we? Yes, sir.
Okay, sir. Quite all right.
Make it faster, sir. It was hard. You didn't know the questions?
No, I was familiar, but...
So he did not solve enough questions because they all looked familiar, not so. Any other person? Yes, sir.
The paper was just all right.
Uh-huh.
Centroids. You didn't teach the doctor.
I didn't teach enough about centroids.
Yes. No, you did.
Huh?
No, sir, we asked others, we thought that it's not going to come because you never, you didn't finish it. But everything was just all right.
I don't know why people are still talking at the back. We are not here for too long, so I'm just trying to get a feedback. I'm trying to understand you, read into your psyche so that when I prepare an exam, it's something that you can respond to. But if Mukamba could last and then there's nothing we're doing, okay? Oh, it's fine. We just move on. Vinachtika, right? So tell me where the issues were so that I know how to guide you. Centroid. What about the centroid? The IgG. Okay, the IgG, the formulas and all that. Anybody else? Yes, sir.
The paper was just fine, but the time wasn't.
The time wasn't.
1 hour, 30 minutes.
You know, this is why I just want to see a hand and then you can talk. Guys, that's how your future looks like. Yes, madam. Hey. Okay. Anybody else? Anybody from the back? Wanabisova? Yes, sir.
You also saw the issue of the marks allocation.
Uh-huh.
Maybe would have allocated the number of marks for a certain question so that it gives a proper picture to the person to say, by solving this, I require this number of marks.
Okay, so let me start with you. For a test quiz, we don't allocate marks because you're expected to answer everything. Only in situations when we are saying maybe answer this question and then you can see how you can work around your figures. Okay, that's you, yeah? With time, and I'm glad you've brought it up. To be honest, it's always been about the time in fluid mechanics. How you beat that is you practicing as many times as you can. Formulas just begin to flow just like that. So you can't be asking me about the IgG formulas. You were here in class, right? I did what? Yeah, so no, I get you. But then I'm also just giving you a feedback that all the formulas that you know are leading into something. Know them by your fingertips. So I think I remember mentioning circles, triangles, a rectangle, a square. Like, know them. The centroid of a triangle. Yes, sir.
Like the question 3 on that test, it was somehow complicated in such a way that it was like I myself personally, I felt like to find where the our like the IGG. So what I did, I just
You're still asking a question? Yes, sir.
About time you said that the IGG, that's the distance from the surface to the centroid.
Okay. Anyway, I think I've gotten
That question is asked actually.
the what?
The same question is asked.
Eh. So, thanks for your submissions, and I've gotten the feedback that I needed. How you proceed? I don't know how you guys started. Are you the high school type? You job alone, so that you're the top of a class alone, or have you started forming groups? Both. First of all, if you're a lone soldier, I mean, it's fine. You know, it's fine. I won't really judge. But I'll tell you something about this world. No, that's too much. I'll tell you something about your future. The future you're training for says that you will only succeed if you work with other people. This thing of I do everything alone, napasa grade 12 alone, where you're going is not going to work. So begin creating relationships. Sir, you're making noise and I'm just in front of you. Begin creating relationships where this person is bringing in this level of expertise and then you do the same. I can create a company, but that doesn't mean that I'll be the finance guy, the marketing guy, the HR guy. You know how companies work, right? Even if it's a very small company, you'll find at least 3 people, 5 people doing that. If you study alone, find ways of bringing other people. They may not be as smart as you, but just find other people that are also doing something that you're doing. This already will begin to shift your mind to work in a certain way. The future does not belong to people that think they have all the ideas and then they'll do everything alone. Give me one example of a company that's just thriving by a sole person. Kulibe. It's a whole team. And this is why people that have sort of dropped out of school and they've made it big in life, they'll come back and shoot at you guys that are called academicians. Waranje Bashan, you've got a degree but you don't have anything. Because the education system begins to make you think, if I'm smart in class, I'm going to be smart in the world. It doesn't work like that. So you will be good at math. You'll be good at memorizing stuff. But there's one other person who knows how to study things, how to interpret things. So bring that person in. I'll tell you a very short experience the time I was here. By the time I was somewhere in second year, we were the 2 of us that were sort of vying for the best students because our GPAs were really close. And from first year up until second year, it was about, I'm the only one doing this. I study on my own. I do everything on my own. And then he was doing the same. The time we're getting into third year, I don't know how, but my roommate, tenze bonse pa class tapunzira bonse, tikaenda kuruma, I don't know vonti vintu vasem. You know what I mean? In the beginning, it was a bit of an irritation. But I said, you know what, let me just help him. But every time he came and I explained stuff to him, I discovered that I'm understanding things on a different level. By the time we're doing third year, first semester, my GPA to that other guy, we couldn't even compare. My point is, if you teach someone, whatever concept that you have, it sticks with you for good. So, whatever we did per test, look, create groups. Maybe it could be the 2 of you, the 3 of you, work like that. What did you solve here? How did you go about it? Because Ngamzembeke is that I'll come back here and solve those questions. Come on, man. I've been teaching for the past, I think, 10 years. I'm just tired. Why do you think I'm recording this stuff? I'm recording this thing, I'm putting it on YouTube, I'm done. Like, I'm just done. I want to do other stuff. The next intake that will be coming, I'll just go like, you know what? I'll send you some YouTube links. See you in an exam. That's why I'm doing this.
Wow.
Okay, maybe I'll be coming from time to time, but I won't be here as much as I am with you. The world has moved. We need to take advantage of the technology. I bought this thing, it was like 19,000.
The same thing.
That camera, right? You should Google it. It's a Sony 6100. Very good camera for vlogging. But it's something that I saw that, look, I don't want to teach anymore. Like, I'm tired. So my point is, but what you can do, and what I can offer is support. So you and the group, you calculate those questions if you're unsure about them. Then you see me when I'm in the office. So we went like this, and we did this. This is our answer. What do you think? That's how you learn. One better. Okay. So today we're just doing an example, an addition to what we already did. Which day was this again? It was last week, yeah? So we began talking about the dynamics of water, not so? This can be interpreted in many ways, eh? Do we have anyone just to erase this? Okay, anyway. So you have this example in your modules. Yes, so you have this in your modules. What page is this, sir? Is it open there? Okay, so it looks something like this. We have this in our modules, not so? So I would just like us to just go through it, solve it together. I don't think it will take more than 30 minutes unless people are maybe we'll be making noise at the back and they won't get what I'm saying. But it's a very simple, concept that's going to sort of cement what we began talking about last week. So I remember introducing the formula of discharge of the flow rate being equal to area by velocity, right? We talked about this? Yes, sir. Okay. So I'm just going to dictate just the question itself and maybe draw just the question itself. All right, so let's just call it a problem. Problem. So I'm dictating. Water flows from point A to point D. Water flows from point A to point D. Are we there? Water flows from points A to points D and E as shown. Water flows from points A to points D and E as shown. So water is flowing from this point to point D and E as shown. All right. Some of the flow parameters are known, comma. Some of the flow parameters are known. I'm going to need something I can just erase here. Otherwise, it's our neck. Some of the flow parameters are known, comma, as shown in the table. As shown in the table. As shown in the table, full stop. Determine the unknown parameters. Determine the unknown parameters. Determine the unknown parameters. Determine the unknown parameters. Okay, so I know we do have that question, but okay, so the table with some known parameters given. Economy is getting harder. Okay. All right. So we have a section here. Then we have a diameter. We have a flow rate. So this diameter is in millimeters. Our flow rate is in cubic meter per second. And then we have velocity. Okay? So you can write this so you can just skip, but we do have this very question in our module. There's a 300, 600, a question mark, and a 150, a question mark. Then there's a Q3 is equal to 2, Q4 is equal to a 0.5, Q3. We have a question mark, 1.2, and a question mark. All right. So I'll try to work on this space so that we can be filling in. Okay. So I'll get right into it because we need to beat this time. So, usually when you're given something that's got some values and some values are missing, look for one that has got almost complete values. Okay, so if I begin with the first one, it's missing 2 values, it makes my work really hard. The second one, I think I can work with this. It's just one unknown, which is here. Are we together? So I'll start from there with BC. And BC, this is the section of the pipe that we're dealing with. So it's bigger, as you can see, it's 600. AB is smaller, it's about half of that. So let me start by tackling or finding the flow rate. So flow rate in this instance is just, what is the cubic meter per second, otherwise known as? Discharge, not so. Just the flow rate, just the amount of water passing through at a point at the cross section of the pipe. So we can start with that. One thing that we do know is that, I don't know if we wrote this, but discharge is equal to, you need an area of a pipe multiplied by velocity. So this is what we're working with, and so it can be broken down to this point, area by velocity. From the diameter, I can find myself an area, not so. So that one is sorted. This one is what I'm looking for. Velocity, so we have. So I'll just go back to the Q. Area pi diameter squared over 4 multiplied by velocity. Area can also be found as what? Pi r squared? It can also work, but usually when you're dealing with a diameter, it's easier to work with one that has got such denotions. So pi diameter has been given as a 600. What we're working with are meters. So careful what you're given there as the units. So today it may be a millimeter, but tomorrow it's a centimeter. So know when to convert what. So you need to be there. So the diameter is a 600 millimeters. You divide this by 1,000 to give you a meter. It's 0.6, right? Divided by 4. By velocity given is a 1.2. Your answer should be, I came with my calculator. I don't trust yours, you guys. What are you getting? What are you getting? So you should be getting a 0.3. 0.3. Okay, let's leave it to 3 decimal places. Huh? What are the units? Okay, so we have this guy figured out. So that's a 0.339. And the units are already seated there. So you have your mark there. Are we together? I move on. So if I have this, there's a relationship that I know that can work where I can throw this value to become that value. We said that Q1 is always equal to Q1. So the volume of water that is entering this pipe, which is AB, is just basically the same as the volume that is getting into BC. Does that make sense? So the principles that we covered last week, they really come in handy here, because if you miss that, then it becomes hard on what you work with there. So in short, your discharge in AB is the same as the discharge in BC. So you can say discharge in AB is equal to the discharge in BC. That means, so we can say QAB is equal to QBC, which is equal to a 0. What? Do you agree that this is BC? Do you agree that the volume, the discharge here is BC? Yes. Because we're working under BC. Are we together? Yes. And we understand that these values are the same. So if this is true, we can go back to our formula again and then just plug it here. Are we together? What value should be here? 0.339. Sharp, boy. 0.0. No stress, Apa. But it takes you to know what you are doing. So if you have figured these values out to be the same because of this principle, then you can try to find the unknown. Are we together? So, so AB is equal to area by velocity. I'm trying to make velocity the subject. So my QAB, I already have it, divided by my area is going to be a pi. The diameter divided by 1,000 is what? Remember, we are here. And the velocity, therefore, is AB. 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 Are we together? What is my area if I'm going to divide this into a meter? 0.3, right? Raise the power. And since we are good mathematicians, we have no problem where the 4 is coming from. Yes? 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 Yes. Did I mention we? We're moving at the speed of light. So we got mathematicians so that we don't spend time on making what the subject. We just get the principle, the rest we already know. So this is the formula I'm working with, and just so try to punch that in. 0.3 raised to the power 2 multiplied by pi raised to the power -1 multiplied by 4 multiplied by 0.339. What are you getting? 4.1? Okay, we can just leave it there. So that's your velocity under AB. So in this AB, the velocity, what I was running at was a 4.8, just there. So, for accuracy's sake, I want you to, I think I mentioned this, find a calculator you can be loyal to. Are you getting me? Find a calculator you can punch in all of these values without you writing anything on the paper. Can you do that? You're not getting me? I'm saying get a calculator and get so comfortable with it that you can punch the whole lot of this and get you an answer without writing numbers down. You are talking about there is no time, like time was little in the test, right? This is where it comes from. You want to start first of all writing down the denominator. Ngamwasanga, mwise divide in. Ngamapwisha, you multiply, and you're writing all those things. We are not interested in how exactly these values are turning out. As long as one, you've shown us the formula. Two, you've plugged in the values that are supposed to be there. The final thing I want to see is just the final answer. There is no need to 0.3 to the power 2. Why? Because 0.09. I don't need to see that. Nobody needs to see that. Be professional. And that's how you beat time. Because if you're going to, you multiply this by 4, mwalemba. You multiply the denominator, mwalemba. Again, you divide mwalemba. Bro, you're eating on time, okay? So find a calculator that you can work with. Something that can allow you to start with this, find the answer, divide it into the numerator, multiply by everything. These are some tricks that you want to adopt if you want to really be fast and if you want to beat time during this test. Because I can assure you, even with exam, people complain that time wasn't enough. Okay, so we have found these two, and that's about it. Can I erase this? Yes. So for the sake of the guys at the back, of which I'm wondering if they're even seeing this. Do we have a question so far? No question, I. So we move on. Okay? Yes, sir. So these are millimeters, sir. Or at least according to the test, to the question. But then be careful, today it will be a millimeter, but then tomorrow I may decide to just put it in centimeter. You are always working with, your formulas need you to always work with the meters. So just be careful with the one that's been given so that you don't fall into a pit. All right, so we have solved for this, we have solved for that. Can we get to CD? All right. So CD says, and it's giving a relationship of, and I think I mentioned this when we met. When water is flowing, it reaches a junction. It decides how much of it is going to CE and CD, and that mostly is dependent on the diameter. Are we together? So I know it hasn't been drawn to scale, but these pipes are not the same. And because they are not the same, this means that when the volume is coming, it will need to be split into that value and that value. Are we okay? Okay. So how do we split it? Again, we are good mathematicians. This looks very easy to me. So they're saying Q3 is equal to Q4. You do understand that there's a 1 here, right? And if we still remember our mathematics way back, the way I can find my Q3 is just equal to a 2 divided by a 3. If I multiply this by Q, the Q which is coming in, all right? So which is a 0.339. What value am I getting? So remember, this volume is the one that is coming through. So I'm just finding a way of splitting it into, are we together? So 0.226. So in short, let me do this. All right, so CD. CD or Q4. Okay, so this allows me now to come and say my Q4 is equal to a 1 over a 3 multiplied by the initial volume which is coming in, which is just still maintained here, 0.339. .113. If you work around these values, can they fit here? They do? So if I'm going to get this value, in fact, let me just maintain it as 3. If I say, and this is me just trying to test and prove if my math is okay, my Q3, which is this value, if I can say 0.226, is this equal to 2 multiplied by 0.11? You can literally mark yourself. If this does not balance, then it's not working out. But then is this working? If it's working, then your math is okay. You can move on. Welcome to engineering. Where's the confusing part? Yes, sir. Q2? So in this case, which one is Q2? This one? Yes. And then Q4? Q4? Yes, that's the same. Exactly. It can also work. So the combination of these two, right, should be equal to that. This is what we discovered last week, not so? Yes. So if I can say, let me just change this a little bit. So the volume or the discharge in BC should be equal to CD plus discharge of C what? This is what we're doing. So these proportions have just been given to you, telling you how when water reaches this junction, split up. Are we together? Vambeka? Yes. Yes, sir. They are parts, sir. There's the 1 and the 2 here. This is just mathematics. Who's your lecturer in mathematics? Mr. Kopigwa? No, we can't go back to that, guys. All right, so I'll leave it up to you. This is just pure mathematics now. My concern is just to tell you of the principles, how water flows, and what relationships do exist. Are we together? This is just pure mathematics. All right. So once you find these values, you can take them back and just plug them here. Which one is Q3? Which one is Q4? Okay. So if you wanted, if it pleases you, you can even say, well, I know this value now, and it's called what? 0.226. And I equally know this value now, because that was just something to test your math, 0.113. And then if you have these, you're halfway done. So from everything that I'm seeing, I think it's easier to begin with that, or you can do with either. I think let's start with the CD. So with the CD, it wants us to find the diameter, which is the question mark there. And then so we can say Q3 is equal to area by velocity. I want a diameter, and the diameter can only be found in your area, not so. So I can say pi diameter squared over 4 is equal to Q3 is what? 0.226 divided by the velocity, which is 1.4. I can multiply this and take the 4 up and the pi down. And if I lose these guys, that's how you move fast if you want to solve calculations. I told you, as a marker, I'm just interested in one. Show me the formula you're dealing with. Then show me the values that exist in that formula. The next thing, show me the answer. Chapwa. Imamu aramba pene, change your subject to the formula. We are not interested in that. Kale wanguzo. Are we together? So you punch in that value now. What are you getting? So my D is 0. Let me have your attention, guys. We are almost done. Just pay attention, okay? So 0.45, maybe 3. These are meters, all right? These are meters, but our table says give us the values in millimeters. Are we together? So multiply this value by 1,000 just to give you a value in millimeters. It's 450 also. All right. So meaning your diameter in this case is a 453 millimeters. So you can come here and just plug in your 453, and this is in millimeters. Are we together, guys? We move on. Can I erase this part? Okay? Anyone left behind? So, meaning this table now tells you that the diameter of the pipe leading to CD is as this big. Okay, so yes, it's bigger than AB, but it's less than BC. The drawings are never drawn to scale, the ones that we give in a test or an exam. But your numbers never lie. They will tell you exactly what you're working with. Are we together? So this has been found. We can just move on to the last part. They want us to find the velocity. So Q4 is equal to area 4, velocity 4. Velocity 4 is equal to Q4. What's Q4? 0. Divided by our area says pi. The diameter is 150. Remember to convert it into meters. So this is a 0.15 raised to the power 2. You know there's a 4 down here, and you know what to do with it. Just take it up, because we're good mathematicians like that. All right. What are we getting? Okay, that's assuring. Okay, so my velocity says just a 6.4 will do, meters per second. 6.4 meters per second. Nishapo Asovai, how long did we take? 20 minutes, 30? I think about 15, 20 or so. So, this means that your AB is about this, and then it's got this flow rate, and then this is the speed running in it. And then the rest is also true. The principle is just the same, all right? Water coming in should be the same as water leaving. What's the relationship between discharge velocity and the area? Pay attention to the units given. So today these are millimeters, tomorrow they may be centimeters. The math that was here, the ratios, that's pure mathematics. All right? So pay attention to it as well. Velocity is there. Okay. Any questions? Any questions? Sounds like everything is clear, or people are confused. Anyway, so like I said, I know you guys are, you're engineers, you're smart. Go through on your own. Let me have your attention. Go through on your own where you are not sure. And that's after you've cracked your brain to work your way around it. Then you consult. All right? Just consult, boy, where do you think he got this value? The module has also solved. It may not have done it the way we have, but it's similar, right? Yeah. Usually modules or what we deliver, it's one of the, we find the easiest ways to get to an answer. But then if you think this is way too simple, you can find a harder way of finding answers, right? Yes. Okay, so we'll see you on a Thursday. I'll communicate with Mr. Robert. It looks a bit shaky. Okay. All right, guys. We'll see you. Bye-bye.